Welcome to the next chapter of matter. In this chapter, we will discuss matters regarding gas, liquid, and solid. For liquid, the learning objective will be one is on the intermolecular attractions. The other one is general properties of liquid. This is the difference between gases, liquids, and solids. This has previously known by you. Gases can expand to fill container. Liquids will retain volume, but will have the shape of the container, whereas solid can retain volume and shape as well. So let's jump next to intermolecular and intramolecular forces. To understand the difference between intermolecular forces and intramolecular forces, it's easier if we can look at the example based on diagram. So what we have here is hydrogen chloride. So the intramolecular forces is actually the covalent bond between hydrogen and chlorine in the molecule, whereas intermolecular forces or attraction is the attraction or the interaction between the molecule, not inside the molecule. The first important intermolecular forces is dipole-dipole interactions or attractions. This happens when we have polar molecules. So polar molecules, as we know before, have partially positive and partially negative. So you can imagine the partially positive and the partially negative between the molecules will interact among each other. The second important intermolecular forces is hydrogen bond. It is almost similar to dipole-dipole attraction. It happens when you have a polar molecule, but for hydrogen bond, it is specifically when hydrogen is covalently bonded to a small, highly electronegative atom, usually FON. So it's easier to remember. If you have hydrogen bond to F, O, or N, then you have hydrogen bond. So for example, the most famous molecule is water. So you can see H2O, the hydrogen is bonded to oxygen in the molecule. So it is partially positive where the oxygen is partially negative. So there is an interaction between partially positive hydrogen in the molecule attracted or interacted with partially negative oxygen in another molecule. So this strong interaction or attraction is called hydrogen bond. Next one is London forces, or known as van der Waals interaction. So van der Waals it's not just happens to polar molecules, but it also can happen to non-polar molecules. So what happened is the movement of electron. So due to at certain points that the electron has polarized at certain places, it sort of produce a negative or partially negative area and a partially positive area. So this will induce some attraction between the molecules. If it is a small molecules, then the forces are not significant. But if it is a very long or a very bulky molecules, then the London forces or the van der Waals forces is significant. Next one, if you have ions, a mixture of ions and a molecule, a polar molecule. So the ions, for example, cation can induce the partially negative, whereas anions can induce the partially positive towards its negative or positive charge. So this will create what we call as ion dipole or ion-induced dipole attractions or interaction when you have ion and neighboring polar or non-polar molecules. Okay, let's watch this video, which is more interesting and with a lot of examples on intermolecular forces.
Between molecules. So atoms within a molecule make covalent and ionic bonds with each other, but molecules also participate in interactions with other molecules. Let's look at the different types. First, we have ion-ion interactions. Large ionic solids are held together by these networks of ionic bonds, which are the strongest
Okay, this is the strongest, this is not interactions, but this is more on electrostatic interaction.
Molecular force, because they involve formal charges. After that, we have ion-dipole interactions. So first, we must understand what a dipole is. The covalent bonds in a water molecule are polar because oxygen is more electronegative than hydrogen and will pull the electrons in the bond towards itself. Because of the bent shape of the molecule, when we combine these vectors, we see water has an overall dipole, or a side of the molecule with some electron excess and a side with electron deficiency. Dipoles can make electrostatic interactions because the partially negative side is attracted to positive charges and the partially positive side is attracted to negative charges. So when sodium chloride dissolves in water, the sodium ions make ion dipole interactions.
Okay, so this is an example of ion dipole or ion induced dipole, okay, where the chloride negative charge will interact with the partially positive in a molecule, and sodium plus cation will interact with the partially negative of part of the molecule.
With the negative side of water's dipole, and the chloride ions make ion dipole interactions with the positive side of water's dipole. Each ion can make several of these interactions, which store a lot of energy, which is why sodium chloride will dissociate in water in the first place. Next, we have dipole-dipole interactions. As you can guess, this is when dipoles interact with each other, as with pure water. When in liquid form, water molecules will move in such a way so as to always be making electrostatic interactions between the negative end of one dipole and the positive end of another dipole. In this case, these dipole-dipole interactions qualify for a special title, hydrogen bonds. This is when dipoles generated by NH, OH, or FH bonds interact with each other.
Okay, hydrogen bond to F, O, and N.
These are just especially strong dipole-dipole interactions. They are especially strong because these are the most electronegative elements.